When you're asked to find the angular and linear speed, you need to be familiar with a few formulas. Now, first of all, I want to talk about this S. S is going to represent your arc length. So it's the distance from one point to another point based on this angle theta here. Okay? And the arc length is going to depend on the length of your angle and the length of the radius. So you can see if I had my arc length was close to this center point, then my S value would be a lot smaller than if my radius is a lot bigger. Okay? So we have this equation here that the arc length S equals the radius times the angle. And then we also know let me add that on there, that the linear velocity, that's v, or linear speed, is the arc length over the time. Okay, so it's the arc length over the time. That gives us the linear velocity, the change in this distance over time, basically. Okay. Now the angular velocity is the change in the angle over time, so that's this formula here. Angular velocity equals the change in the angle over time. We also can, using these two formulas, you can convert that to this formula right here, which is you're going to use this. The linear velocity v equals the radius times the angular velocity. Okay, now let's go ahead and you're going to see I'm saying angular velocity out of habit. So in ALEKS they're asking for the angular speed, so when I say speed or velocity, we're talking about the same thing here. Okay. So for the first part of this problem, it asks you to find the angular speed. Okay. So we want the angular speed of a point on its equator in radians per day. And that's 24 hours. There's 24 hours in one day, right? So we're going to want to know that. Okay, so we need to know the angle over time. And so basically you can see here that the angle, we're talking about it rotating 10.7 hours in one rotation. So that's 360 degrees, but in radians, 360 degrees is the same thing as 2 pi. So that's 2 pi radians. So this is going to be 2 pi radians, call them rad, okay, over the time, and that is 10.7 hours. Okay, but it asked us to find this in radians per day. So we're going to need to do a little conversion here. Okay, so I remember doing this a lot in chemistry, and you'll do it in physics and all sorts of other things. So what you want to do is you want to convert your hours to days. So when you're doing that conversion, if my hours are in the denominator, I want to put the hours in my conversion fraction. I want the hours in the numerator so that I can cancel out the hours. That means days or day go down here in the denominator. So I know in one day is 24 hours. So that's my conversion fraction here. I can see if I multiply these together that the hours are going to cancel out. And you basically have, so 2 pi times 24, that's 48 pi over 10.7. And this is going to give me radians per day. Now, if I go ahead and plug this into my calculator, 48 times pi divide by 10.7, that gives you approximately 14.093. And then it asks us to round the, oops, sorry, I didn't get that in here, but it does ask you to round your answer to the nearest whole number in ALEKS. So this is about 14 radians per day. ALEKS asks you, the ALEKS program asks you to calculate, so angular velocity is 14 radians per day, and so that's the first part. The second part is going to ask for the linear velocity on the equator in miles per day. Okay, so the equator has the radius of 74,900, well, the diameter is 74,900 miles. Okay, so we're going to need to take half of that for the radius. Okay, so and basically we're going to, since we already know the angular velocity, let's use this formula right here. The angular velocity equals the radius times, excuse me, the linear velocity equals the radius times the angular velocity. So just to kind of simplify our calculations, I'm going to go ahead and take that 74,900 miles, and I'm going to divide that by 2 to get right, because this was the diameter. So half of that will give me the radius. And then we're going to times that by the angular velocity. And so the problem in ALEKS actually asks you to not use any approximate values until you get to your final answer. So we're going to use this 48 pi over 10.7. And this is radians per day. And so I'm going to put radians here and the day down here just to keep myself straight here. Now, so we're going to go ahead and multiply this all together, 74,900 times 48 times pi divided by 21.4, because that's what 2 times 10.7 would give us. And that is going to be approximately 527,787.565. This is miles per day. Okay, and we round that to the nearest whole number, and that's going to be 527,788 miles per day. All right. And that is how you find linear and angular velocity.